This unit that we're working on is called forces. A force is defined as a push or a pull. So if you have an object and you push on it or you drag it, you're exerting a force on it. You're pushing down, pulling up, all these are forces. Now when we look at forces, we tend to start with Newton's 3 laws of motion, because Newton's laws of motions sort of organize forces for us to understand how they work. Now the first rule is inertia. Now the first law is the law of inertia, and that says that when an object is at rest, it will tend to stay at rest, and an object in motion will tend to stay in motion. So if you are sitting off in space, you will stay there and not move. If you're exerted, a force is exerted upon you, pushing you forward, then you will continue moving on and on and on, unless there's another force exerted on you to cause you to stop. The second law is often referred to as F equals ma, and what it says is that when an object undergoes a force, then it will accelerate. And so we have the fact that acceleration is proportional to force over mass. And the third law is the action-reaction law, so that if you push on a wall, the wall will push back. If you stand on the ground pushes back on you to keep you up. If you're off skating and you're facing someone on their skates and you push them away from you, you also feel a force pushing back on you. All these are examples of action-reaction. So if we look at an example, if an object feels a force of 20 newtons and it's 5 kilograms, then we can calculate the acceleration from Newton's second law using F equals ma. We rearrange to solve for acceleration. We divide the force by the mass, we get 4 meters per second squared. And so that is the acceleration the object feels. Now notice there's a little arrow above the A reminding you it is a vector. Acceleration has direction, and so does force. Force can go 20 newtons to the right, 20 newtons up, 20 newtons west. It can do all those things because it is a vector. Now the next thing we look at is gravitational force. And gravitational force explains that any object will exert a force on any other object. Anything that has mass will attract anything else with a mass. And so if you have two planets, they both exert a force of gravity on each other. The sun exerts a force of gravity on Earth. The Earth exerts a force of gravity on the moon, and vice versa. And the moon also exerts a force of gravity on Earth, and that's how we notice tides. Any two objects at all will exert a force of gravity on one another. And so we can use the formula for force of gravity, where G is the gravitational constant, the universal gravitational constant, m1 is a mass, m2 is a second mass, and d is the distance from the center of one object to the center of a second object. Now in some books you might find that instead of d you'll have r, and it means the same thing. It's just with r it tends to be used more for planetary motion. So if we have, for example, the moon orbiting Earth, and we have from the distance from center to center, we have the radius of the moon's path. And so sometimes you'll see the formula written as F equals gm1 m2 over d squared. Now if we look at these two objects up above, a 500 kilogram object and a 1500 kilogram object that are separated by 5.5 meters, they exert a force of gravity on each other. And so if we plug in the numbers, we can see that they exert a force of 1.65 times 10 to the minus 6 newtons on each other. Now, we will do a lot of force of gravity problems, and even kinematics, the forces will drift into there, and we need to know a few things about force of gravity. Now, because we use so many force of gravity examples, you'll need to know one thing. Now, if we look at this problem, any object that I solve that's on the surface of the Earth, a car, a person, a dog, a ball, a box, all objects will have things in common. No matter which object you'll be using, like this, for each object it will have the same gravitational constant, it will be using the same mass of the Earth, and any object on the surface of the Earth will have the same distance to the center of the Earth. Now because these three numbers are always used over and over again, and they don't change. If we work them out, we can substitute it with the letter g. So instead of writing all this out, if we're looking at an object of, an object that's on a surface of the Earth, we can, instead of doing F equals gm1 m2 over d squared, we can use mg, where g is known as acceleration due to gravity, 9.8 meters per second squared. But again, that it only applies for objects on the surface of the Earth. And even then, we have to be careful, because if we're talking about someone in an airplane, they're no longer on the surface of the Earth. The value of gravity will be less. If someone's on Mount Everest, they're further from the surface of the Earth, gravity might be around 9.79 or 9.78 there. And on the Earth itself, in the Arctic, gravity will be more like 9.79, whereas on the equator, because the Earth bulges out around the equator a little bit, gravity will be 9.81. So if we're trying to find the force of gravity on an object on the surface of the Earth, or a person that's 50 kilograms, then all we have to do is mg, where g is 9.8 meters per second squared, and we find that the force of gravity on a person on the surface of the Earth is 490 newtons. We also refer to that as weight. Now I put a star here to remind you that it's actually one of the most misused terms ever in science. Because people use weight all the time. What's your weight? And people will say 55 kilograms. What's the weight of that bag of oranges? Oh, it's 5 kilograms. Whenever you talk about kilograms, that refers to mass. Mass is how much matter you have. Mass doesn't change. If you go to the moon, you still have the same amount of matter, and that doesn't change. What does change is the force of gravity on an object. Because the gravitational pull from the moon is much weaker, your weight will be much less. So your weight will change depending on where you are, because your weight is force of gravity. Your mass never changes. It's the amount of matter you have.